Okay, good morning. For math today, we are going to do a review class. Tomorrow is our map test. So I want to review with us things that you want to go over. You have taken these tests. You know the types of questions they have on the test, and we all want to do our best. So let's use this class to review some things that might be on the test. Things that we've done in class this year, things that we're working on, like with the algebraic expressions. Okay. So why don't you get out a piece of paper for you to work on so you can do work at your desks and I can do stuff at the board so you can work out some of the things we're going to be working on. So if you have paper, if you have a notebook paper, we're going to correct later. We're taking a pause from our lesson, our COs that we did last week, and we're just preparing for the test. So math test tomorrow is what we're preparing for. So let's talk about mean, median, and mode. I know mean, median, and mode are always on the math test. How do I find the mean? What do I have to do to find the mean? Josie?
You add all of them up and then divide the answer and how many numbers are in it.
So we're going to add all the data up and divide by how many numbers there were. So let's do this as our data. Okay, I'm going to do these. I'm going to do these as my data points. What's the first thing I want to do when I get data, Gregory? I'm going to find the mean, median, and mode. What's the first thing I do? Put them in order. So we need to rewrite our numbers in order. So I have to rewrite those numbers. Now, if I'm going to find the mean of them, I need to add all the data up. So I need to add these numbers up. 1 plus 3 plus 5 plus 5 plus 7 plus 9 plus 10. So 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 5 is 14. Plus 7 is 21. Plus 9 is 30. Plus 10 is 40. Now, truth be told, when I did it in my head the first time, I matched up my tens to make it easier to do mental math. And I said 1 and 9 is 10, 3 and 7 is 10, 5 and 5 is 10, and we have 10. So that's 10, 20, 30, 40. So when you're doing mental math adding, find those little things. Add up your tens. Those are easy numbers to add by. So if we have 40, next it says divide by how many numbers there were. On our last test, this was one of our review questions, and people forgot to divide. How many numbers do I have, Tristan?
7.
1, 2, 3, 4, 5, 6, 7. Oh boy. What is 40 divided by 7? It's not a simple number, is it? See if you can do the math. when you get those crazy decimal points, we only need to go out to like the 10th or the 100th place. They're not going to want you to go all the way on and on and on. So we're going to round. So let's review how we divide. Long division. Oh boy. What's the first thing I look for? What's the first number I'm going to look at here? Anthony?
7.
Okay, 7. How many times does it go into 40? Will? 5. Because 7 times 5 is 35. If we went up to 6, that would be too big. That would be 42. So I do 40 minus 36 is 4. Oh, not 36. 35. My goodness. 40 minus 35 is 5. Am I done? Do I say 5, remainder 5?
No.
No, that's what we did back in 4th grade. We did remainder numbers. We're big now. We know how to do decimal points. Remember, when we need to keep going on, we put a decimal point in, put a decimal point up. It goes straight up. We add a 0. Bring your 0 down. How many times can 7 go into 50? 8 and 7. 7 times. 7 times 7 is 49. 50 minus 49 is 1. I said go out to the 100th place. Remember, this first decimal place is the tenths. We want the hundredths. We're going to have to go to the thousandths so we can round to the 100th. So how many times can, oh, no, we got to put a 0 on. Bring my 0 down. How many times can 7 go into 10? Nolan? 1 time. 1 times 7 is 7. 10 minus 7 is 3. We're going to add another 0 on because I said we want to go out to the thousandths place. How many times can 7 go into 30? Ryan?
3 times.
4.
3. Oh.
4 times. 4 times 7 is 28. 30 minus 28 is a 2. But we can stop there because I said we're going to round to our 100th place. So we need to remember that that first decimal place is our tenths. The second is our hundredths. And that third is our thousandths. Remember, there is no oneths. There is no one place. So if I'm going to round 5.714 to the 100th place, what would my answer be?
Yep.
How do we round? Oh, all these wonderful things we're reviewing. It's been a while. We haven't worked with rounding. Peyton.
So, if we want to round it to the hundredths place, we look at the 1 in the hundredths, and then you look at this thousandths place.
Mm-hmm.
And since the 4 is not, since it's not, it's not over 5.
The 4 is less than 5, so that means our 1 stays the same. So our mean is 5.71. If that thousandth place had been 5 or higher, we would put it up to a 2. So it would be 5.72. But because it's under 5, we keep it the same. So let's look at our mode. What does mode mean? Gregory?
The
Most. Which number do we see the most?
5.
Tristan?
5.
The 5. There are 2 5s and there are singles for all the rest. So our mode is 5. What does median mean? Nolan?
The number that's in the middle.
The middle number. So because we have an odd number, we actually have a number in the middle. Make sure that you're doing the middle of our ordered data. Don't look up here and go to the middle. Some of us have made that mistake. Put them in order. That is not our middle. 10 is way at the end. We want the middle data of them in order. Our middle number is 5. What if I put an 11 on there? What would my median be? Hello, the skate. I do. It's Monday. Thank you very much. All right, bye. It's Monday. So because now I have 8 data points, I have 2 numbers in the middle. 5 and 7 are now both in the middle. I can't put 5 and 7. I can only have one middle number. What do I do, Kira?
Yeah, I had them both. You basically find the mean of 5 and 7.
You find the mean of those 2 numbers. So we have 5 and 7. That equals 12. Here's my reminder. And then I need to divide it by how many numbers? There are 2 numbers. So I divide by 2. What do I get, Ryan? 6.
You also could have just
Even though 6 is not a number that was in our list, that is our median number.
You could have just found the middle of it, like that.
Sometimes it's easy, and we look at it and say, oh, it's a 5 and a 7. The middle between 5 and 7 is 6. Sometimes it's as easy as that. It's not always that easy. Okay? So you're right. I could have easily just looked at it and known, but this is how we actually figure it out. The last thing that they have on the math test is the range. How do I find the range? And we're going to do the range of our original numbers. How do I find the range of the original numbers, Aiden?
Add the biggest and the smallest number.
I am not going to add them. What am I going to do? Subtract them. So I'm going to look at my biggest number of 10, and I'm going to subtract my least number of 1, and that is my range. So remember when we were doing the box and whisker, and we had to find the interquartile range and the full range? We subtracted the biggest from the smallest. We subtracted that biggest by the smallest. All right, so we covered long division with decimals. We covered rounding those decimal places. We've covered mean, median, mode, and range. Let's review fractions. Oh, fractions. Love fractions. 3/4 plus 7/8. No, not 8. That's too easy. I am not making it that easy. 3/4 plus 3/5. Add it up on your paper. See if you remember how to add fractions. What is your first step, Mia? Finding the common denominator. So I look at my 4 and my 5. What is the least common multiple of 4 and 5? Tristan?
20.
20. What am I going to multiply the 4 by to get to 20? Mia? 5. So whatever I do to my denominator, I have to do to my numerator. 4 times 5 is 20, so 3 times 5 is 15. What am I multiplying the 5 by to get to 20, Nolan?
Wait, hold on. 4, it's
I already know what the answer is, but it's 4 times 3, and that equals 12.
So I multiplied the 5 by 4 to get to 20, so I have to multiply my 3 by 4. And you are correct. 3 times 4 is 12. Now that we have a common denominator, we can add them together. So how do I add? How do I add fractions? Tristan? The denominator stays the same. We just add our numerator. 15 plus 12 is 27. So, am I done, Ryan?
Don't you have to simplify it?
Yeah. We have to make it proper. How do I make 27 20th proper? Anthony.
It's 27.
I need to see how many times can I take that 20 out of 27? How many times can I take a 20 out of 27, Anthony? I can take it out one time. 27 minus that 120 has how many as a remainder? How many are left over, Tristan?
7.
7 are left over. What do I do with that 7? That remainder becomes my new what? My new numerator. Denominator stays the same. Now I have to look, can I simplify my fraction, 7 20ths? Can I go any smaller? Do they share any factor that's bigger than 1? They do not. So my answer is 1 and 7 20ths. When we're subtracting fractions, what do we do?
Say it like the exact same thing.
The exact same thing, it's just we subtract our numerators. Adding and subtracting are very similar. Let's look at multiplying fractions. Let's do those same fractions. 3/4 times 3/5. How do I multiply those? Tristan.
You have to have a common denominator.
We do not need a common denominator for multiplying and dividing. What should I do, Gabby? Multiply going across.
Yeah.
3 times 3 equals 9. 4 times 5
See, I did.
equals 20.
Yeah, see it? Wait, oh, I simplify and simplify.
Can I simplify this? Do they share any factor bigger than 1? They do not. So it is as simple as it goes. What about if we're going to divide? 3/4 divided by 3/5. What do I do? How do I divide fractions? Regan.
You flip your second fraction and then multiply it.
So if I'm going to flip my dividing to multiplying, I need to flip my second fraction to its reciprocal. And then I can multiply going across. 3 times 5 is 15. 4 times 3 is 12.
That can also be.
Am I done?
No, you gotta simplify.
What can I do, Nolan?
15, you gotta subtract 50. Wait, well, hold on. Yeah, use how much times can 12 go into 15? Only one time, and then you subtract them. And the leftover is the top, and then the bottom always stays the same.
So I'm going to make it proper because 15 is bigger than 12. I have to make it proper. So I can take a 12 out of 15 one whole time, and I'm left over with 3. That's my new numerator. Am I done, Will W?
Yeah.
No.
Why not?
Because you guys didn't simplify it.
How can I simplify it?
Wait, what?
I just got an answer. Alright.
What are you going to do to get the answer?
Just
Divide by what?
3.
I can divide a 3 out of both 3 and 12. That is a common factor that they both share. 3 divided by 3 is 1. 12 divided by 3 is 4. So my answer is 1 and 1/4. How are we feeling about fractions? Is it coming back?
Yes.
We're remembering? Let's talk about those algebraic expressions that we started our unit on. Because algebra will be on our test. Shh. Let's see. How can I find my n? I'm taking us a couple steps forward into this unit because I'm trying to get us ready for this test. So I'm showing you what we're going to be doing in a couple days. Knowing what we know about our algebraic expressions, who thinks they know what we should do? Anthony?
6.
Tell me how you're solving it. What steps should I do?
6 plus 6 equals
2. No.
So I'm going to walk us through the way that we solve it, because sometimes we look at a problem and we go, oh, I know the answer. I can figure the answer out. Let's walk through how we get to that answer, so when we get to one that we don't know off the top of our head, we know how to solve it. The first thing that we're going to do is we always want to get our variable by itself. Nolan, do you know what I'm going to do first?
I have the answer, but
Yeah, so did Anthony, but I want us to know how we get to that answer. First thing we want to do is we want to take out our constant, the one that doesn't have a variable. We want to eliminate it from the side with the n. What we do to one side of the equal sign, we need to do to the other side. So if we want to zero out our 6, if it is plus 6, what's the opposite, the inverse of plus 6?
minus it.
Josie? Minus 6. So I'm going to subtract 6 from both sides. So now I have 2n equals 12.
Yeah.
Because I subtracted my 6 out. So now how do I get n by itself? I have 2n. What does that mean? 2n. What operation am I doing, Kira?
multiplication.
Yeah, because remember there's a multiplying when the number's next to the variable. What's the opposite of multiplying?
Division.
Dividing. So I need to divide both sides by 2. Remember that fraction bar means divide. So when you see that fraction bar, you are dividing the top by the bottom. So 2 divided by 2 gets you a 1, right? 2 divided by 2 is 1. We don't have to put the 1 because 1 times the number is always the number. So it's just, I said at the very beginning, we want n by itself. Now we have n by itself, but we have to do our last step. Because what we did to one side, we have to do to the other side. What is 12 divided by 2, Nolan? 6. So some of us were able to look at it and we say, oh, 2 times 6 would be 12. 12 plus 6 would get us our 18. It's not always so easy. So you need to know the steps to go through to solve for that n. You're always going to do the opposite to get your variable by itself. Let's do another one. This is going to make our next couple objectives a whole lot easier because I'm giving it to you a little early to prepare us for our test. Let's do I'm giving us an easier one with easier numbers. Try to do the math that I just showed you, working out our opposites. First go to your constant, and you want to do the opposite for our constant. So if it is -3, Anthony, what are we going to do? What is the opposite of -3? Aiden? +3. What we do to one side of our equal sign, we do to the other side of the equal sign. So -3 plus 3 gets us 0. 1 plus 3 gets us 4. So I'm going to rewrite my equation. So now I have n over 2. What does it mean when it's over 2? What operation is that, Will? Division. So what's the opposite? Multiplication. So I need to multiply both sides by 2. Because I'm always going to do the opposite. Times 2 divided by 2 gets us n by itself. 4 times 2 is 8. Now what you always want to do is double check your math. Does anybody know the way that we would check our math? How can I check my math, Nick?
You like it the opposite way to like see if you get back to where you were.
I'm actually just going to take my n, what I solved for n, and I'm going to put it in for n. So 8 divided by 2 is a 4, minus 3 equals 1. So if I plug in what I think my answer is, and I actually put it into my problem, it should equal the right thing. So to check your work, you're just going to be putting your numbers in. How are we feeling about that? Is it making sense? Kind of. We're building up to it. We're not quite there yet with our objectives. I'm just giving us an idea because I know there's going to be some algebra on here. They're going to give us some easier algebra like we started off with. So if they did 3n equals 12, can we figure that one out? Yeah, because we know 3 times what equals 12. We know that n equals 4. The way we get that is we divide by 3, divide by 3. Okay. So we know that there's going to be some algebra like that. We know there's going to be some geometry with our graphs. Being able to read the bar model, the box and whisker plot, the scatter plots. So remembering how to read those graphs. Does anybody want me to go over any of the graphs? Will? The box and whisker. So a box and whisker. Let's see. Okay, so there's my number line. I'm going to make my box like this. So what do those lines mean? Who can tell me what the median of my data points are? Think about what the median, where would I find the median? What do you think, Brian?
Would it be 10?
It would. This middle line is my median. So my median is the middle. So that tells me half of my data points are above it and half of my data points are below it. So my upper quartile, my lower quartile. So where is the middle, the median of my upper quartile? Nolan?
14.
Nope.
What?
This is my interquartile range is my box. So the median of my upper quartile is this end of the box. So the upper quartile is at 12. The lower quartile is at 8.
Oh, I was thinking the wrong. I was like the median of like the sides.
So remember that this goes all the way up to 16. We're not going between 10 and 16. We're looking at our lines up here. So you were looking at the 10 and the 16, right? We need to look at where our lines are. So our box tells us that interquartile. So we know that there is half of all of our data is here, and half of all of our data is here. Then there's 1/4, 1/4, and 1/4 here, and 1/4 here. Because those halves are broken into half. Half of a half is a fourth. So we've got our middle. So half of that numbers are above it, half of the numbers are below it. Then we have the middle of that top half, the middle of the bottom half. So kind of coming back a little bit. There's not too many problems on the box and whisker that are going to be on the map test. So don't stress too much about that. There's a lot more of the dot plots and the scatter plots and the bar graphs. I've seen a lot more of them on map tests. Those are a lot more common. So just really think through the bar graphs and the scatter plots, how to read how many are in each section. Nick?
Can you do slope?
Yeah, we're going to do graphs next. All right. So, where is the x-axis? Josie? It's going across. The x-axis goes across. So the one going up and down is my y. Remember when we do ordered pairs, it goes alphabetically. The x comes first, then the y. What numbers are at the origin? Josie? Yeah. Right in the middle where the two intersect, that's where my zeros are. And then, oh my.
What?
Then we go out from there. It goes positives to the right, negatives to the left. Oh my.
What is all this?
I don't know. It's being fun. Yeah, I like fun sometimes too, not always. So positives to the right, negatives to the left, just like our number line. Our y-axis is like our thermometer. Positive numbers go up. Negative numbers go down. So now if we want to plot an ordered pair, we want to look at our x first. If x is 0, we're going to be at the 0. Then our y is 5. We go up 5, and we get that ordered pair. So now let's say our next one is 2, 3. So I'm going to do my x first, go to my 2, and then go up 3. And there's my line. So now the question was, can we review the slope? Remember, the slope is the rise over the run. The rise is your up or down. The run is to the right. When we're doing our slope, we have to remember positive slopes, we go up. Negative slopes are when we go down. So I start reading left to right. So I'm going to start at my dot that's the farthest left. And I'm going to count how many times I'm going to go down to get to my next point. So if I'm going down, what does that tell me about my slope, Landon? It's going to be negative. So I'm going to put that negative down right away so I don't forget it's negative. I'm going to go down 1, 2. So that's going to be my rise. And then I count how many over. 1, 2. So my slope is negative 2 over 2. What is another way of saying that, Landon? Yeah, because 2 over 2 is the same as 1, and it's a negative. So my slope is a negative 1. How are we feeling about that, Nick?
Good, a lot better than I was. Because like ones where they're going instead of going to the right, the ones that are going to the left. The ones that are going the slopes are not going to the.
So you always want to start on the left and go to the right. And if you go down, then you know it's going to be a negative. If you go up, you know it's going to be a positive. But everything else is the exact same. You either go up or down, and then you go to the right. Let's see. Negative numbers. There's always negative numbers on the map test. Let's do negative 5 plus 3 equals what? Tristan?
Negative 8.
Is not negative 8. Remember, if you need to, you will have scratch paper. Draw yourself a number line tomorrow. Oops, it's not negative on the right. It's positive. So draw that number line to help you remember which way we're going. So here we're starting at negative 5, and we are adding 3. So if we're going to add, which way on the number line are we going to go, Tristan? To the right. So we're going to add 3. 1, 2, 3. So it is negative 2. You see how we got that, Tristan? Yeah. What about if we have negative 5 minus 3. Landon?
Negative 8.
Yeah, because this time we're going to start at that negative 5, but when we subtract, we go to the left. Okay? Now let's review multiplying and dividing by those negatives. Negative 5 times 4. The first thing you do is the 5 times 4 is what, Aiden? 20. Then we have a negative times a positive. Negative times positive is what? Nolan? Yeah, negative. A negative times a positive is a negative. What if it's -5 times -4?
Then it's positive.
Negative times a negative. A negative number times a negative number makes it a positive number. Anything else that we want to review? Think about what's been on the map test that you guys have done. Think about if there's anything from what we've done in class so far. Okay, I'm going to stop our recording here and tell our friends at home we hope you are doing well and we see you soon.